pH, what is the pH and pOH of a solution which is 1.4 times 10 to the negative 3 molar hydroxide? Okay, well, they want the pH and they want the pOH. Well, I know the pH is the negative log of the hydrogen ion concentration. pOH is the negative log of the hydroxide ion concentration. Well, they give me the hydroxide ion concentration, so why don't I just deal with that one first? So pOH is equal to negative log of the OH minus concentration, which is negative log of 1.4 times 10 to the negative 3. So I just stick in, this in the calculator, I take the logarithm of it, I change the sign, and I end up with 2.85. So notice 2.85 is a much more attractive number than 1.4 times 10 to the negative 3. At least that's many people think. I personally don't think so, but that's fine. I'm a chemist. We deal with pHs, we'll deal with pHs. But don't think it's something different. It's not. If you want to, you are more than welcome to deal strictly in concentrations, and if you ever have to find a pH, just at the last minute, take the negative log of it. No harm, no foul. Now, we want the pH. Well, the pH, we know that the H concentration times the OH minus concentration is equal to 1.0 times 10 to the negative 14. So the H plus concentration equals 1.00 times 10 to the negative 14. Well, let me just stick with 1.0. Let's just do two significant figures here. Equals 1.0 times 10 to the negative 14 divided by 1.4 times 10 to the negative 3. That's going to equal 7.2 times 10 to the negative 12. And then when I take the pH of that, that's going to be the negative log of the H concentration, negative log of 7.2 times 10 to the negative 12 equals 11.14. 11.14. pH 2.85, pOH. Notice something. What is 11.14 plus 2.85? Yeah, you guessed it. It's about 14. Now let's explain why. We said that Kw is equal to the hydrogen ion concentration times the hydroxide ion concentration. Let's take the negative log of both sides. Negative log of Kw is equal to negative log of this whole thing. H plus, OH minus. Well, negative log of Kw is pKw. That's it. Equals negative log of H, that's equal to negative log of H plus, right? Plus the negative log of OH minus. You end up with pH plus pOH. Well, pKw is the negative log of 1.0 times 10 to the negative 14 equals pH plus pOH, because Kw is 1 times 10 to the negative 14. The negative log of that is 14. That's our final relationship. So, for any aqueous solution at 25 degrees Celsius, pH plus the pOH of the solution equals 14. This is just a restatement of the fact that the H plus concentration times the OH minus concentration equals 1.0 times 10 to the negative 14. These are the same thing, except one deals with these numbers, these scientific notation numbers, the small ones. One deals with numbers that are a little bit more tractable. So in any aqueous solution, the product of the hydrogen ion or hydroxide concentration is 10 to the negative 14. The pH plus the pOH of that solution is equal to 14.